complement of 11. So I don't know, you guys, if you notice in this example about the complement of 11 of A and the probability, probability of the complement of 11 of A and the probability of the 11 of A. So let's check together. Look here. So we have the probability of A is half, it's half, and the probability of complement of A is the same thing. So if we add them together, if we try to add them together, let me just turn the page right here. So it's going to be the sum of the probability of 11 and the probability of its complement is going to be equals to 1. It means P of A, let me see if I'm okay, I'm good. P of A plus P of complement of A equals to 1, right? It was 1 over 2 plus 1 over 2, same denominator, so it's 2 over 2, which is 1. So, and from this, we understand that the probability of an even is 1 minus the probability of its complement. So its probability of even equals to what? Is 1 minus probability of the complement of even. And the same thing, the probability of the complement of an even is 1 minus probability of an even. So it's going to be probability of a complement of an even is 1 minus probability of an even. So those things are going to help us a lot to find in probabilities. I think we have another example that we can understand better about using the complement of an even in a problem. So let's check with this problem right here. All right, so this problem said, example, your little blue number cube is like a dice, and the white number cube. So it's two dice. One is blue, the other one is white. Yes, at the same time. What is the probability that you do not roll the double? So let's define the even, like let's say A, for example, be that you do not roll the even. So you do not roll the even. You do not roll double, I'm sorry, right? You do not roll double, I'm sorry. I was not talking about even number right here. Yes, you do not roll double, by the way. I'm sorry about that. You do not roll doubles. What means doubles? Is 1 and 1, right? Or 2 and 2, or 3 and 3, or 4 and 4, or 6 and 6. The blue and the white together. So what is the complement of A? The complement of A is that it means that you do. This you do not. You do roll. This is the complement of it, right? This is the complement of it. You do roll doubles. All right, let's try to find out how we can deal with this. And what is the sets of, do we have to find all those numbers? It means the 3 and like the sets of A. The sets of A is going to be what? The sets is better to find the sets of the complement of 11. Then it's easy for us to find out with A. Because so far we just talk about those things. So if we know the complement of 11, the probability of complement 11, we have just to do 1 minus that complement to get the complement of A. The probability, of A, right? So let's check right here. We can do it straight, so we know it's like 1, 1, 1 and 1, 2 and 2, 3 and 3, 4 and 4, right? 5 and 5, 5 and 5, and 6 and 6, right? So how many elements so far? So if I want to say how many elements in C, right here is 1, 2, 3, 4, 5, 6. So 6 elements. Is that right? So only 6 elements. As you can do, of course, a diagram. It means you can if you want to make a diagram with two ways table. It means you're gonna have like you can do that this way if you want. Let me try to do it very quick. 1, 2, 3, 4, 5, and 6. All right, let me do it very quick. 1, 2, 3, 4, 5, and 6, right? So this is blue and this is white. So let me check. I think I have a blue right here. All right, this is gonna be 1, 2, 3, 4, 5, and 6. Sorry. And the white is, let me just keep it with this color, 1, 2, 3, 4, 5, and 6, right? So in this case, just to understand better, otherwise we can go straight and talk talk about the complement of an even. So if we have 1 and 1, right? So if we have 1 and 1, I can have 1 and 1. I can have 1 and 2, right? When you roll the dice, you can have 1 and all the dice, the blue one is going to give you 2. Or it's going to give you 1 and 3, 1 and 4, 1 and 5, 1 and 6. Same thing, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Or you can have 3 and 1. Or, sorry, let me just comma between them. I don't want to, like, you're going to understand it's 26 or whatever, or 15 or 14. It's just comma right here. 3 and 2. I can have 3 and 3. I can have 3 and 4, 3 and 5, 3 and 6. 4 and 1, 4 and 2, 4 and 3, 4 and 4. Yes, 4 and 5, I'm sorry. 4 and 6. And there's, let's go, 5 and 1, 5 and 2, 5 and 3, 5. All those are situations that you can have, right? All those are situations that you can have. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5 and 6. And the last one is 1 and, I'm sorry, 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, and 6 and 6, right? All right, so how many doubles we have right here? So if you check, you see that we have 1 and 1. Oh, let me choose another color a bit quick. All right, so we have 1 and 1 right here, 2 and 2, 3 and 3, 4 and 4, 5 and 5. I'm sorry, I messed it up a little bit. And 6 and 6. It's not 5 right here, okay? 6. 6 and 6. 6 and 5 is right here, and 6 and 6 is right here. So as you can see, look now how many 1, 2, 3, 4, 5, 6. So if I want to say what is the complement of A, is 6 numbers. I can have 1 and 1, I can have 2 and 2, I have 3 and 3. But if I talk now about the simple space, what is simple space right here? Is all possible outcomes, right? How many possible outcomes right here? Let's count them. So simple space, what is N, S, how many elements? I just want to write it like this. So it's elements, right? And elements right here. It's not number 6, I'm sorry, it was a mistake. It was a mistake right here. So how many elements of complement even of A is 6? You can have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. How about now the simple even? I mean the simple space. Simple space is all those elements. So 1, 2, 3, 4, 5, 6, right? For 1, 2, 3, 4, 5, 6. So 6 by 6 is 36 elements. 36 elements. So now the probability of the complement even of A, which is that you do roll double, you will roll double, this probability is N of complement even of A over N of S, right? Which is what? I will just write it down, 6 over 36. And when you simplify, you will have 1 over 6. 1 over 6. Great. So now, if I want to, because they asked me, by the way, they said, what is the probability that you do not roll double? You do not roll double. So now, I found the probability that you do roll double, right? You do roll double. So you can have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So my question now, how can I find that you do not roll double? So this is I have just to go back to what I just said, which is, what is probability of an event? Is 1 minus probability of the complement event. So we just found what is this equals to, right? So let me check if we are in the same page. All right, we're good. You see guys like this? Yes. So we have this one, which is probability of complement of an event, which is 1 over 6. Then we have just to find what is the probability of the event A, which is you do not roll the doubles. So probability of A is what? Is 1 minus the probability of the complement of the even itself. So equals to 1 minus 1 over 6. So you can write it 6 over 6 minus 1 over 6, which is 5 over 6.